Welcome to Sravz technical series. In today's session, we will use LangGraph derivative project called LangGraph Supervisor.py to create supervisor agent solution. So we have a supervisor and a bunch of agents which will process financial data in JSON file. So we have this mutual funds data in JSON format. So this is one of the mutual funds, and we have it in this JSON format. So like this, we'll send a couple of mutual funds and then use LangGraph, a supervisor agent framework to process these JSON files and give us some meaningful reports. So for example, I just ran a report using this data and I got this financial report for these funds. So for these three funds, I got the yield to date in this nice tabular form, and it also gives the yield direction, and all of this is done through LLM supervisor agent framework. So I'll go through the LangGraph and perform some queries. These are the sample queries. I'll perform those queries and then see how the code works, and the code is updated to this location. You can go through the code base here. I'll go through this code base at a high level, but if you have any questions, you can reach me out. So I'll run that code using Python test cases. I just ran one test yield direction, and the code ran and it provided this report which I opened here. That is financial assets yield data for these mutual funds, yield to date for these multiple years, and the direction it shows decreasing. Yield to date has been decreasing over the years. So now I'll run the next test get yield expense ratio. We'll start the test case. We'll let it run in the background. So that test case will get the data for each mutual fund. It will get the yield to date and divides that by the expense ratio. If we go here, we have the expense ratio in the data. So we have the expense ratio and we have YTD, yield to date, yield YTD. So it will divide the yield by expense ratio and gets the data for those three mutual funds. So the test is executed. I'll open the file. So for each code, we have the yield, expense ratio, and yield to ratio. I have the data for FSPTX. So for FSPTX, yield is 0. Yield is 0. And expense ratio is 0.62. So it showed us the yield to ratio. So this is all done by LLM. We're not doing any manual reporting. So I'll show at how the data is being processed. We get the mutual funds data in the JSON format. Then we put those JSON files in ChromaDB, and then we get relevant documents from the ChromaDB, which was all done in the previous sessions. And once we get the relevant documents for each mutual fund we are interested in, we get the relevant data. For FPGRX, we have the yield. FSPTX, we got the yield. We have yield. FPGRX, we have the expense ratio. So this is the most relevant data we need for performing the query. Then we pass this one to the LLM, and then the LLM generates the nicely formatted HTML file which we just saw. Let me run the next query. Get top holdings. I'll let it run. So we again use those three mutual funds. We get the JSON files. We push them to ChromaDB. Then we do a relevant document search like this, and we only get the top holdings from the JSON file, not the whole JSON file. And then we send that relevant documents to the LLM, and then LLM will create the HTML report for us. So it is in process. While that is running, I'll show the code base at a high level. So the test cases are here. These are the test cases I was running. Test LLM agent, test agent supervisor. Yeah, these are the test cases I was running. So if you follow the test case, you'll understand how the code runs. Right? These are right now we are running this test get top holdings. We pick these 3 JSON files and then we run through the agent supervisor. The agent supervisor code is in this directory. So we have llm.py which does the query. Then for each funds we get the relevant documents. You can go through each function. I won't discuss those. We created the supervisor. Then to the supervisor we provided these agents, and the LLM is GPT-5. So we provided that as the LLM model. Then these are a prompt, and then once we submit the query, we get the response in that nicely formatted HTML file. So we got the output for that query, get top holdings. Let me copy this and open the file. Top holdings for FPGRX are these, and then top holdings for this one. So we get a nicely formatted report. We can enhance this one so that LLM generates the reports whichever way we want. I'll run one more test case, test fund summary. So while it runs, so test fund summary got the relevant documents. It's pretty fast. Then it's going to OpenAI. It will send this information to OpenAI, and then we'll wait for the GPT to give us a nicely formatted HTML file. So all that action is happening with LangChain. So we got the nicely formatted report. I'll open that file. So based on the fund summary, we're getting the type of the fund. So PTX is the most aggressive fund. FPGRC, these funds are aggressive, moderately aggressive, least aggressive. So this report is generated by LLM. So like that, I have a couple of more test cases which I won't run now. If you see the cost, it's around 5 cents per query. So it's really expensive query. So we have to see how to optimize this further. I already reduced the amount of data I sent to GPT. So at some point we can, at a later video, I'll see how to optimize the cost. And the code, as I mentioned, is already uploaded there. Yeah, the code is here. And if you look at this line, we do structured response and only get the pre-signed URL. Using structured response, we can force the LLM to send us a response in a predefined format so that we can parse it on our side. So in my structured response, I have a pedantic base model, and I have only one field, and then I'm using that field to get the query response. Query, yeah. So I'm using that field to get the pre-signed URL. This one, pre-signed URL, and that is what I was displaying in the Visual Studio Code. I get a nicely formatted pre-signed URL. In a future session, I'll show you how I'll integrate this into the UI. Right now, I'm still working on the UI, but if you see the UI, in the AI Assist, we'll have a property to pick from the JSON file, and will give a query. Then LLM will send us a response, and we'll display that in the UI. So this way we can make the UI more AI native. Those reports which are dynamic in nature, we can use GPT to create the reports for us. So in a subsequent session, I'll show you how I integrated the UI, Angular-based UI, with the LangChain Supervisor agent model. With that, I'll close today's session. If you have any questions or comments, please reach me out in the YouTube channel or in the discussion tab here. And as I mentioned, the code base is in this directory, and I also pasted the link here. So go through the code base and let me know if you have any questions. Thank you for watching.